Hi. Okay, so a couple of things before we start. First, the terminology. So AngularJS refers to everything before version 2, so everything up to version 1.7. And Angular refers to everything from version 2 onwards, right? We all okay with that? Yeah, we all agree it's a stupid naming convention? Yeah. Secondly, when I'm talking about AngularJS apps here, I'm talking about old AngularJS apps. So when Angular 2 came out, there are a bunch of tutorials and blog posts online about how to upgrade your Angular 1.6 app that was all nicely written in ES6 with components into Angular 2. That's not that interesting anymore, right? Those apps, they've all been upgraded. What's left is all the hard cases, all the old stuff. And thirdly, without the tiers is a complete lie. This is never going to be easy. But hopefully you can learn some things from my mistakes and there'll be less tears when you go to do it. So, the two things that I want you to take away from this talk. First of all, you should upgrade your app. There's a couple of good reasons why you should. Most importantly though, you can upgrade your app, even if it's terrible. So, as we said, I am Erin. I'm a Google developer expert and also a Mozilla tech speaker, and apparently that's not a conflict of interests. I work at a consultancy called Shine Solutions in Melbourne, Australia, and we consult at a large Australian energy retailer who would prefer not to be named. I think it's a bit of a shame because they are doing some really cool stuff, but enterprise. So at this unnamed energy retailer, we have this app. And this app is something that probably a lot of you are familiar with. It's written in Angular 1.4. It's part of a Java project, so the Angular code is actually embedded in a JSP. It's built with Maven, which if you're not familiar with it, is a Java build tool, which has some very specific ideas about how you should do things. And it's a hopeless mess. It has a lot of anti-patterns that I think a few people have talked about with their apps over the last day and a half. But yeah, so stuff like this. Because it's a really old app and it was written before components and componentizing stuff was a thing, everything is in a controller. And there's no real logical boundaries between the controllers. So this was the longest one I found. This is 1,386 lines of code in a single file. And it's not the only one over 1,000 lines. Because old school Angular is quite bad at encapsulation, we've got a bunch of stuff like this, where we've got a reference to a parent controller, and then we've just added a function to it. We've just changed its API from the child. Why not? And because this code was written by people who, JavaScript wasn't really their thing, so they do a bunch of stuff that JavaScript devs probably wouldn't write. So we've got this app, and we've accepted that there's two big problems with it. First of all, it's got huge security vulnerabilities in it, right? It's relying on a bunch of old libraries. They've got vulnerabilities in it. This is a problem. And secondly, it's a really terrible developer experience. And this is a problem because it makes it really hard to attract and retain talent, which I'm not sure what it's like here, but in Melbourne, trying to get good front-end devs is really hard. So we decided that we needed to solve these problems. And we figured we'd start with the security vulnerabilities because that's a little bit easier to measure. So we measured it using a tool called Dependency Checker, which is an OWASP tool. It's available as a Jenkins plugin. And we use this one because it can scan our Java code and our JavaScript code. And it can also do .NET code. It's not going to tell you if you've got security holes in your code, but it's going to tell you if any of your dependencies have known security vulnerabilities. If you're a little bit luckier than me and your JavaScript code lives in its own sort of repository, you can actually just use npm audit for this same thing. So we scanned our code, and it came up with 6 high severity vulnerabilities, 31 medium severity, and 18 low severity in the JavaScript code alone. These are mostly cross-site scripting vulnerabilities. And we're like, well, this is a problem. We need to fix it. So we need to improve our security. And to do that, first of all, we needed to convince business that this was something that we needed to prioritize, right? That this is important. So how did we do that? Well, we spoke to them in a language they can understand. Our dev lead went to our business and basically explained to them what a data breach was and how many companies in Australia had had those recently and just how much it had cost them in like fines and user confidence and things like that. And our business are actually pretty good, so they agreed that, yeah, this is a bit of a problem and we should probably do something about it. So we needed to fix all these vulnerabilities. How did we do that? We upgraded all the things. So we upgraded Node and NPM, just mostly to give us better tooling. We upgraded Angular JS from 1.4 to 1.7, which was okay. It's not really that difficult. The hard part, though, was we had to upgrade all of our dependencies. So everything that relied on a specific version of Angular, plus any dependencies that had security vulnerabilities in them themselves. And this was by far the hardest part. These dependencies hadn't been upgraded in 4 or 5 years. And you know what happens over time like that? Yeah, the APIs all change. So when we wrote this code originally, we were using Bootstrap UI, if people are familiar with that. It's components for Angular. We were using version 0.8.3. And in version 0.8, if you wanted to put a calendar on a page, you wrote some code like this. When we updated, we had to update to version 4. And in version 4, if you want to put a calendar on a page, you write something like this, which is a little bit different. And the only way to find these differences is basically to run the code and see what breaks. So obviously the best way to do that is to run tests. So good tests are really essential if you want this process to go smoothly. And when I say good tests, I don't just mean a lot of tests, because we had a lot of tests. I think we've got something over 900 unit tests, and they were pretty useless, to be honest. We had tests that look like this. So this is a test that's testing that we can add a phone number to a customer's contact details. So we're setting up the phone number, and we're calling the function to add the phone number. But if you look at the expects in this test, they're of this format. So we're expecting this particular private method of the controller to get called when we do this thing. And this test isn't really giving us any information, right? It's testing the implementation of our function instead of the intent of the function. So we know these is going to get called because we can look at the code and see which functions it calls. But we want to know what the outcome was. What were we aiming to do when we called this function? So really we want expects that look like this, right? So when I add a mobile number, then I expect that type to have been added to the list of types, and I expect this label to have been updated. So this tells us what we expect the outcome of our thing to be. And this is much more useful because if we're just testing the implementation, when we refactor our code, the implementation changes. So the fact that the test fails doesn't really tell us anything. Okay, so yeah, if you don't have good tests, I would suggest fixing that, but honestly, it's pretty hard. So good luck. The bad news is I don't really have a good solution for this. If you're in this kind of mess, you can do your best with it, but it's going to be a hard process. The good news is that there's ways to stop this from happening again. And there's a bunch of different ways you can do this, but the one that we chose is that we now break the build for security vulnerabilities. And we do that using a tool called SonarQube. So when there's vulnerabilities found in our vulnerability checker, our build is broken and we can't release anything until we upgrade those dependencies. Now it's not perfect because obviously vulnerabilities get found before the fixes get found. So sometimes we do have to let things through. And we're not going to upgrade everything because we're only picking up security vulnerabilities, but it's a good start. And we've got like a solid business case for keeping these things up to date. All right, cool. So once we had dealt with all those security issues, now we needed to deal with this terrible developer experience. So on top of all those things I showed you before, this code is written in ES5, so it's missing a whole bunch of nice features, and it's written using all of these Angular utility functions. And I don't know about you, but I have no idea what this code is doing. It's so hard to read. And I'm going to change it before you work it out. It's built using Gulp, which is pretty common for apps of this age. Nothing wrong with Gulp. But it doesn't have proper dependency management. So we just have all of our node modules files listed in the Gulp file, and then we just concatenate them all together. And if we miss one, well, it breaks, I guess. I don't know. Maybe there's something there that we don't need anymore. Yeah, it's not ideal. The app is organized terribly. This directory called components has 98 subdirectories in it. Does anyone guess how many components are in it? Because it's 0. So that's fun. And basically everything in this app is in global state. So you touch something and you just don't know if it's affected something else. So it's a nightmare to work with as a dev, and we just needed to fix it. So what do we do to get a better developer experience? We decided on a 2-step process. Step 1, move to a modern framework. Step 2, burn the old code base in a fire, because it needs to go. So at the start of this process, we discussed which framework we wanted to move to, and we looked at the various options, and spoiler alert, we're at an Angular conference. We went with Angular. Basically, we had a bunch of experience in Angular. We've got a bunch of devs who know Angular. And most of our devs aren't front-end specialists. They're sort of full stack. So I don't think that they have the experience to be picking up a new framework as well as learning, keeping up with the old one. So we decided to stick with what we knew. Because we stick with what we knew, of course, we went with ng upgrade, which is the standard way to upgrade your apps these days. Now, if you look at Angular IO and see the documentation for how to upgrade your app, the first thing it'll tell you is a bunch of stuff that you need to do in preparation. So it says, you need to make sure that you're following the AngularJS style guide. And that's got lots of useful information that, ideas about how you should split up your code that we are not doing. Use a module loader, migrate to TypeScript, and use component directives. So yeah, this is all a load of crap. You don't even worry about it. You don't need to do any of this stuff. Instead, we're going to see how we can do this without any of that. Well, some of it, sort of. So we need to start by tidying up our code a little bit. And there's 2 things we need to worry about here. First of all, we need to make sure that our HTML is valid. Now, this might seem obvious, but when I was doing this with our code, I kept getting these weird errors that I couldn't understand. And when I looked in the code base, I found a bunch of stuff like this. This is a self-closing div tag. I don't know why anybody would want to do it. It's not valid HTML. But a browser will let you do it. And because AngularJS passes your HTML to the browser as HTML, it works. It's fine. It's OK. Angular, though, parses your HTML, turns it into JavaScript, passes that to the browser, and then turns that back into HTML. And Angular will have none of this. It will not let you have all this illegal HTML. So I don't know, if you're getting weird errors that you don't understand, maybe you've got self-closing div tags. The other thing that's a bit of a bigger deal is dependency injection. So in AngularJS, the dependency injection is kind of magic. So you would declare your service, and you put in your parameters that you want dependency injected, and the dependency injector would just work it out by magic, right? It knows the name of your parameter is going to match the name of the dependency, and it's just going to figure it out. Unfortunately, when you run your code through a minifier, it ends up like this. And the dependency injector says, what on earth is A? I've got no idea what you're talking about. So instead, we need to name our dependencies explicitly using strings, which we can do like this. Doing this is kind of tedious though, because it's a lot of replicating stuff between two things. It's easy to get them out of sync. So usually what we'll do is automate it with a tool called ng-annotate. And ng-annotate is available as a Gulp plugin, as a Grunt plugin, and as a command line tool, which is great. What it's not available as is a Webpack loader that works with the Angular CLI. There is a Webpack loader, but to use it, you've got to eject your app, which we don't really want to do. So yeah, ng-annotate in our build pipeline is out. So what we need to do instead, or the solution we used, is just to actually annotate the existing files in the source code so that the annotations are there. I wouldn't want to do this in a code base where we were actively working on it, because keeping those annotations up to date is annoying. But because this is our AngularJS code, which we're not really intending to touch anymore, we figured we can just add the annotations in and then move on with our lives. And to do that, we do this. So this is a handy bash command. It's going to find all of the files in the current directory and subdirectories that end in .js, and then it's going to run ng-annotate against it. It's going to pass in each of the file names as the file to be annotated, and then it's going to pass in that same file name as the output, so the annotations would just end up back in your source code. And then you need to put \semicolon on the end, and I don't know why, but it won't work without it. So that's half of the bash that I know. And then you end up with your files like this, and everything will work. So once we've done that, we're ready to move on to the next step, which is switching to TypeScript. This is a Nintendo Switch, so this slide is very funny, okay? The thing with switching to TypeScript is that we really need to use ES modules, right? So we do need to set up some kind of module loading system. The reason for that is that the TypeScript compiler starts with like an entry point at the top, a single file, and then it finds all of the dependencies of that file and all of the dependencies of those dependencies, and it builds like a tree structure, and that's how it works out which files to include in the build. When you've got something like this, that won't work. There's nothing for the TypeScript to deal with. So instead, we need to move this mess into proper imports. Again, I don't know a way to do this automatically. We basically just went through all of those files and turned them into imports like this. The other thing you need to do is import all of your actual app files. This one you probably don't want to do manually. I don't know about you. We've got something like 300 controllers in here. I don't have time for that kind of thing. So now we can use the second bit of bash that I know. So again, we're just going to find all of the files that end in .js. We're going to exclude all of our test files, and we're just going to output all of those file names into a file. Then we can use a find and replace or whatever to stick the imports and the quotes and stuff. And we can grab all those imports we had before and stick them in the same file. And now we've basically got all of our dependencies explicitly managed. We can start creating our app entry point. So to do this, we need to find the entry point of our AngularJS app, which is going to be the one that declares the top level module. And we need to import that. So you can see that below our node module imports, we're importing app.js. And then down the bottom there, we just need to also export it so that we can grab it from TypeScript later. Right, so now we've done all of our preparation, we're ready to start using the Angular CLI. And we can just go in and just, like we would normally, ng new my app, and we're ready to go. Except if you're using something like Maven, which has ideas about your folder structure that aren't the same as the ideas that the CLI has. So this is our folder structure. We've got a bunch of Java stuff, and our Angular app lives under the web app directory there. But our package.json lives up the top at the project root so that we can run commands and stuff from up there. This is a little bit inconvenient, but it's not completely insurmountable because the Angular CLI project structure is mostly configurable. You can go into the angular.json and just anywhere where it says /source, change it to the actual location of your project. There is a bit of a problem with it. I find that generating components and stuff, it doesn't recognize the source location. It'll just generate them in the current directory. So the really high-tech workaround for that is to change into the directory that you want the components to be in and then generate them. Cool. From then on, you can actually just go to angular.io and follow the usual upgrade instructions. It's reasonably straightforward. Once you do that, you're ready to start writing Angular. And this is where the fact that our app isn't a nice Angular 1.6 component-based app starts to come into play. So there's 4 things that you might want to do in a hybrid app. The first is that you might want to write a brand new Angular component and downgrade it and use it inside your AngularJS templates. This you can do, even if you're using like Angular 1.4 templates and it's all old and controllers and ng includes and whatever. This will still work. They're fine. The second thing you might want to do is take an existing AngularJS service and upgrade it to use in an Angular component or an Angular service. Again, this will work fine. Even if your services are factories, they're still going to be OK. The third thing you might want to do, well, this one's a bit less likely, I think, is use a new Angular service in an existing AngularJS directive or controller or whatever. Again, it's fine. You can just do it. The last one is the trick. If you have an existing AngularJS directive that you want to use in a new Angular component, now, sometimes you can do it. The rule is that you could do this if your directive could have been created as a component. So if you could have created it using angular.component, then you will be able to upgrade it. And the rules about whether you can create it as an Angular component are a little bit complicated. So first of all, it has to be an element. You can't upgrade attribute directives. Secondly, it needs to have a controller and a template. It can be a template URL, whichever. It needs to have an isolate scope. So I think most things probably should be OK with that. I think most of from like Angular 1.4 onwards, they would generally isolate scope. This is where it starts getting a bit problematic. It needs to use bind to controller. Bind to controller didn't come in until Angular 1.6. So if you're using 1.4, it's not going to have that. But you can probably do a pretty simple one-to-one swap for scope and bind to controller. Lastly, it needs to have no compile or link function. So far, in our code base, I have found 0 directives that meet all these requirements, so I haven't been able to upgrade any of our directives. But I think that's kind of been a good thing because it means that I've had to rewrite them as components, and now I have less code in that old horrible code base. So yeah, I don't think it's necessarily a problem. It's just something you need to be aware of. Cool. So now we've got all of this upgraded. What does the future look like? For us, the future is micro front ends. We're using NX from Narwhale. And we have a setup something like this. So we have our hybrid app, the existing upgraded app, which consists of a dashboard page and a bunch of child pages. And then we have a new repo that is built using NX. So it's a mono repo with a bunch of micro front ends in it. And whenever we build a new child page, we build it in the new repo. And then we just link to it from the old repo, and they're all deployed on the same domain so they can share state via cookies and stuff like that. We currently have a project underway to also rebuild the dashboard page as a micro front end. And then we can link to the existing pages from that. And then for a while, we're going to run both of the pages in parallel, do some A/B testing, fine-tune the new app, and then we can get rid of the old one. And then we can replace those child pages as and when we need to. So we've got that hybrid app, and now we're sort of moving out of it as well. So yeah, we've moved to a modern framework, and I wouldn't say we've actually burned the old code base on a fire, but we've definitely set it alight. Done a couple of other exciting things. So we've started building a component library, also using Angular, which is going to allow us to share UI components between our Angular apps and our Drupal apps, because we have a static site in Drupal to match all our apps. We've built some services that we can use, some libraries that we can use to share services between our mobile app, which is built in native script, and our web apps. And we've started experimenting with Angular elements. So we're using those to create A/B tests that we can then inject on a page, either an Angular page or a Drupal page, because they're web components and we can do whatever we like with them. So yeah, that's our story. It took 4 months and probably 2 devs working on it for 4 months to get from a pile of chocolate mousse to a really fun app that everybody really enjoys working on and is a lot more productive with these days. So hopefully you've learnt some things. You've got some take-homes from this. First of all, tests are really important. You really need good tests. Secondly, a stitch in time saves 9. The sooner you can get on this, the easier it's going to be. But most importantly, it absolutely is possible, even if you are in a terrible, terrible situation. Cool. Thank you. The slides are available up there.
Thanks, Erin.